Swayam Prabha. Digital India. Educated India.
In the just previous lecture, I spent some time on determination of permeability value, and I have mentioned that there can be permeability can be determined from laboratory test or field test. I have shown the laboratory test in my previous lecture. Now, let me discuss one or two methods in the field, and this field method is having pumping test. I have told you that it will be considered pumping test only. I will consider in this class. So, I will discuss now pumping test. Again, pumping test, various field condition, the condition will be different, and equation will be different, and observation will be different. So, we will discuss one by one. So, let me come to that. So, this is a field permeability test, and when we consider the pumping test, we have to see the water bearing layer actually, and water bearing layer can be there in two ways. One actually confined ways and another is unconfined ways. Unconfined means there is an impervious layer bottom, and then over that there is a constant water level up to some height, and topmost level of water which I have discussed, that is a water table or groundwater level we say, where actually pressure is atmospheric, and that from that that water will be there at a particular level. And then, as I have mentioned before also, if you make a borehole, then that borehole actually initially will show the water which is equal to water level same as the groundwater there. Now, if from this groundwater actually we can pump out, and if we pump out from this, that means from here if I pump out water, then water actually from the surrounding zone, from this zone actually water will enter to the well, and so that entering how quickly it will enter, it depends on the permeability of the soil. So, if the fine grained soil, that the flow will be very less and pumping quantity will be very small. If it is a coarse grained soil, then permeability will be very good and pumping rate can be quite large. So, we have to follow certain procedure to conduct the test, and this test actually I have shown here number of things. This is the borehole, and borehole has initial diameter is R naught, and while doing this actually we make two observation well also. That observation means we will continuously pumping, and then at a particular distance, suppose that distance is R1 and R2, at a distance R1, and this is distance R1, one observation well is kept. At a distance R2, there is another observation well is kept. And this observation well, when this water will be pumped out, that everywhere water level will not come down uniformly, because of this there will be drawdown. The maximum drawdown will be in the well itself, and when you will go away from the well, the drawdown will be comparatively less, and at some distance you will not see any drawdown, and that distance is called radius of influence. That means up to what distance, because of this pumping there is no effect. So, that is what also, that is actually say h is the height of water from the impervious layer, and then that is the one, and number of things, that means at a particular time your water level in the well is h naught. So, these are the things to be observed. That means, when I am taking pumping out, that you have to see that we are pumping at a constant rate. That means, initially pumping may not be constant, because you have to, that is this is valid for steady state condition. So, the quantity also should be constant, then only you have to take measurement, otherwise it is not correct. So, when steady state discharge is arrived, then only after some time you have to constantly discharge it, and then from that time you have to observe what is the water level at observation well 1 and what is the water level at observation level 2, and those things can be correlated to K value in terms of R1, R2, H1, H2 and all those things. So, that I will show in the next slide. You can see consider an intermediate distance r from the center line of the pumping well and let the height of groundwater level above the impermeable layer during pumping be h. So, that means what? I will just show here, this is the well and this is the water, and then this is the drawdown curve, and we have shown that two distant R1 R2 two observation well H1 and H2, but instead of that I am take any arbitrary distance R1 sorry not R1 R, and there actually this height is H. That is the thing is explained from this statement. And then hydraulic gradient I is equal to the slope of the HR curve. So, del H by del R. So, this curve actually HR plane del H by del R. The area of imaginary wall of the cylinder of radius R and height H, that means actually if I consider here, if I consider, that means this is the well and at a distance R I can imagine a well of radius R. There is another well I consider. That means, if I consider that well radius r, that means through that well periphery water is entering. So, that means what is the area through which, that means a flow quantity of flow is q times v into a, and so that means I have to find out the area. So, over which area the flow is taking place at particular location. So, that area actually 2 pi r is the periphery, 2 pi r is the periphery, and h if you multiply, this is the vertical cylindrical surface we are getting, vertical cylindrical surface. So, that means it is something like this. So, this is h and this is the 2 pi r, this is 2 pi r. Then based on that, that is the 2 pi r you have got, then q become a k I, and that means, and again this is 2 pi r and h is the area and k and the I is del h by del r, and from there if I simplify q into del r by del r 2 pi k h del. So, that means r is a variable and h also is a variable, other things are all constant. So, h is variable. So, r and h variable and r is sorry r also variable, r and h is the variable. So, that to be integrated. So, if I put in the integral form, so it comes like this. You can since we have two observation well R1 R2, I can put limit R1 to R2, and q also I can put, q already is there 1 by r del r, this is actually variable, and 2 pi k outside I can keep constant, and h del h is the variable. So, I put this and limit height h1 and h2, and if I integrate and simplify, then I will get finally equation for k q ln r2 by r1 pi h2 square minus h1 square. So, this is the one equation. So, what are the observation actually? Observation is I have to fix two observation well at a distance r1 and r2, these two are known, and I have to observe after steady state discharge what is the head observation well, what is the height, what is the observation of well 2, what is the observation of well 2 1, what is the height. These things you have to observe, this to be fixed and this to be observed, and q to be measured quantity, that steady state seepage discharge, and then I can put in this equation, I can get the value of coefficient of permeability. Now, in various application, particularly this permeability, the concept is application one of the important application area is that in the construction site, sometimes we have to dewater. That means if suppose I have to construct at a level of suppose 10 meter, but water table is at 2 meter, that means for construction purpose I have to lower that 8 meter water level or even more to reach, otherwise with water I will not be able to excavate and I will not be able to do the construction. So, that dewatering work sometime some calculation we do where actually we need to find out the radius of influence. So, that radius influence sometime given by some author, that is actually Contd. He has given in this form r equal to under root 12 t by n under root q k by pi. So, q, all those things are quantity to be noted, porosity of the soil to be noted, to be known, where n is the porosity, r is the radius of influence, t is the time during which discharge of water from well has been established, and k of course initially we can measure by pumping observation well, and after determining the k, the next step we can find out r I. This is one way to determine r I. There are many other empirical equation also there, that is actually suppose r I equal to, one equation is C into H minus H naught into under root k. So, this C is the constant, is given for well 3000 value is a constant, and H minus H dot actually original water height and well final water height, that how much you have to lower, the difference of that actually is H minus H naught, and under root k s that will be put in the meter per second, and then if I use this equation finally I will get radius equal to radius of influence equal to in meter. So, this is one way. There are many other ways in the literature available, this is another way. So, if you can find out this radius of influence, then sometime we need not have a observation well, I can take the well itself one observation well, and since I know radius of influence, what is the water height and what is the distance. So, that is the thing it is shown here. You can see H 1 can be considered at H naught, that means what, that is water level in the well, and R 1 equal to R W, that means radius of the first observation well is nothing but R W and radius of the well, and H 2 equal to H, that means second observation well, what is the height, is the height of water above impervious layer, that itself at R 2 equal to R as substituted. So, these things if I substitute whatever equation we have developed in the last lecture previous slide, if I substitute those we can get this equation. So, this equation what it says, Q is the again seepage discharge quantity, R is the radius influence, we can calculate either this or this way, R naught is the radius of the well, and H is the height of water table above impervious layer, H naught is the final water level after pumping, what is the level came, and if I put this equation then I will get the value of k. So, this is another way of calculating k, and next slide, actually sometime we need to find out what is the at a distance of x, what is the water height, you sometime want to find out, because excavation area sometime is a large, suppose in a particular point we are doing this, but at a distance from this construction site, what is the water height, that to be determined. For that actually we can do this way, H 1 equal to R naught at R 1 equal to R W and H 2 equal to R and R 2 equal to R. So, that means we have taken there observation pumping well itself is one well, observation well. Here actually what we are doing at a distance R 1. So, R 1 I can substitute by R W, and H 1 H naught can be substituted by H 1, and H 2 will be H at R 2 equal to R. So, this thing if I put, then this equation will be modified to this form, that means at a radial distance R and what is the height H. This is this one if you fixed, that is about 10 or 100 meter distance, what is the value of height as to be determined. If already k is determined, q is determined, H naught is determined, then H can be determined, which so that is the simple, if I simplify this one H in this form, q by pi k ln r by r w plus h naught square. From this equation one can find out the value of h. That means, when you are continuously taking out from a well, and as I have told you that if this is the well, water table is here, but your drawdown curve will be somewhere here like this. Now, I want to find out, I know the observation well what is the value, but I want to find out maybe somewhere beyond this or somewhere in between what is the water height. Then this is the way I can do a small calculation and can find out. Next slide is actually, as I have told you that water bearing layer can be unconfined or confined. This is a case of confined aquifer. This is a confined aquifer, and this confined aquifer, actually confined means what? Actually here you can see it is same as previous, only thing this is actually maybe very thick clay layer, and this is impermeable layer, this is impermeable layer, and this is the layer sand which is holding the water. So, and this water may be under pressure also. It is not necessary that water in between, maybe water discharging from here. So, if I make a borehole from here, then whatever water level it will show in this borehole, that is the equivalent water level you can imagine. So, suppose if I make a borehole and water level is coming somewhere here, that means that is the initial water table to be assumed, and then by pumping, suppose I have to bring down somewhere, or I want to find out the permeability value. So, that means I can also previous like previous case I can make different observation well. So, if I get initially pump well is here and observation well here, then everywhere will be water level will show at this level. Now, when I will taking pumping out, then suppose water level is coming here, and then your drawdown will be from like this or like this, and if water goes from this level to beyond this, equation will be slightly different. I will discuss the water level when above this. So, if I do this, then you can see again same as previous, you have taken radius of this well is 2 r. So, that diameter is 2 r naught, at a distance r 1 and r 2, two observation wells are there, and earlier it was actually your above impervious layer, what was the height of water table, that was h. Here also same, I can consider whatever water level it shows, that will be denoted h. Additional term here which is constant here, that is the thickness of the water bearing layer, which is HA. Now, what way it is different from the previous one? The difference from previous one is here like this. If I imagine one well now, suppose at a distance r, if I distance r, if I imagine a well, suppose this is the well, and I can imagine at a distance r, suppose here this is at a distance r, this is distance r, that is distance r. It is looks unsymmetric, but is not because of my sketch is looking so, but this is a center and at a distance r. So, that means all around the well, this I can imagine a particular well, and then through which actually water will be entering. An earlier case, what you have done, if the drawdown curve was like this, then our impervious layer was this, then our area through which water was coming was 2 pi into r into h. The h was variable there, but here since it is above this, there is no water is entering, from this water is not entering, here also water is not entering. Through which water is entering? Water is entering through this only this much depth. So, in this case, our area through which water is entering is nothing but 2 pi r into this h a, which is constant here. So, that is the only difference from unconfined to confined. So, we will show that in the next slide, that when we are considering your area through which water is entering to the well, that was 2 pi r into h, which was h was variable. Now we have considered we are also considering another imaginary well at a distance r from the pump well, and in that case and in that well through which water is entering, that is actually 2 pi r into h a, which is actually constant. So that's what only difference. So that will show in the next slide. I can show, you can see here that that is the thing I have said. Area of imaginary wall of the cylinder of radius r and height h. So that we have considered. Now if I make whatever height h I make, but actual area of flow that through which this is better to write h a actually, because I make a cylinder, but water is entering through this much height cylinder. So your cylinder is like this, but cylinder is restricted through which water is coming is only this. So cylinder height may be any height, but I will take only this is the h a, that much I will be taking. So if I take h a or h whatever, so 2 pi r h. So like previous case, q equal to a k I, the formula was there, and that is actually 2 pi r into h. Now a is substituted by this, and in the previous case it was substituted by 2 pi or small h, which was a variable, and k and I is same as previous, del h by del r, and this if I simplify, then q del r by del r 2 pi k h del h. Now this portion is variable, and here only this portion is variable. So this now if I put in the integral form, definite integral form here, and two distance if I put two observation well at r1 and r2, and that part can be integrated, and here actually 2 pi k into h and del a is to be integrated, and what a observation height at h1 to h2. So these two which I have shown in the previous slide, the h1 h2, that means two observation well, that two observation well at a time, but at a particular situation after pumping some time steady state pumping, that h1 and h2 reached here. So if I do integrate these and simplify, finally I get k equal to q ln r2 by r1 2 pi h h2 minus h1. So you can see the difference from the previous equation, it was 2 pi and here it was a square, and here actually so ultimately dimensionally it has to be correct. So that it is easy to remember. Previous equation it was q ln r2 by r1 2 pi k 2 pi h2 square minus h1 square, and here actually square has gone, but one constant height has come. So that is the one. Finally this, from this equation one can find out the permeability by pumping test, and that too which is applicable for confined aquifer. Now confined aquifer, when you draw constantly for a longer time, then water may level, that in the well water level may come down somewhere here. This was the level impervious layer, and this is the impervious layer, the water level coming here. If water level come down here, then actually there will be a different equation you have to use, because water entering through which in this this no longer will be 2 pi into 2 pi r into h a, that will be different. So because of that, that is not, so for that different formulation is there, but I am not going into that. So like previous case also, if I want to find out what is the drawdown and at a distance that, so what is the area of influence, all those things also similarly I can modify, and I can find out that this well itself can be taken under observation well, and at a distance where there is no drown, that can be taken as final observation well, and based on that I can modify this equation and I can find out the permeability value k. And now the permeability and seepage, now that is another thing. So I now explain how to determine the value of permeability, but if you in the often actually in the field the soil is stratified, and sometime Also in the actual construction also we put it in layer and compact, and because of that the permeability in different layers may not be constant in the all direction. A sedimentary deposit may consist of several different soil, and it is often necessary to determine average values of permeability in two direction, one parallel to bedding planes and the other one right angles to it. That means if you have the layer like this, and flow may be taking place in this direction, flow may be taking place in this direction. So, two direction you have to find out the average permeability, because if they are not equal in every layer. Let there be layers of thickness H1, H2, Hn, and the total thickness of the layers is H, and Kx1, Kx2, Kx3 and Kxn be the representative coefficient of permeability in the horizontal direction. And then we can consider the representative coefficient of permeability parallel to the bedding plane, and Kxe be the average permeability parallel to the bedding plane. Okay. So, this is the respective layer, and this is Kxe I am considering as equivalent. So, different layer having different permeability, I have to find out the equivalent. So, I am assuming this is equivalent and these are the respective value. Considering flow parallel to the bedding plane, then Q will be equal to A Kxe into I. If I convert into equivalent layer, this was where A is the total area and I is the hydraulic gradient. So, now the total flow must be equal to the sum of the flow through the each layer. So, suppose if there is a number of layers, flow is taking place like this, and then flow Q1, Q2 plus Q3. So, when it is a parallel, so finally whatever water coming out from this side will be summation of water flowing through each layer. So, that if I consider that, then it will become the respective layer, these are the equation, respective layer, these are the equation, and if I sum it, that should be equal to, because this is this equation is with equivalent permeability. Considering unit width, that means through cross width is 1, then A become thickness itself. Hence, I can express this equation in this form, and if I simplify, then Kxe become H1 Kx1, H2 Kx2, H3 Kx3, Hn Kn, H1 plus H2 plus H3 plus. So, that is in a very brief or very summarized way. If I can write generalized way, I can write this form, that is equivalent permeability of a layer or of a n number of layers when they have different layers having different permeability like K1, K2, K3, K4 like that, then finally equivalent permeability can be expressed this way when the flow is taking place parallel to the bedding plane. Now, the other case when the flow is taking place perpendicular to the bedding plane, considering flow perpendicular to the bedding plane and like Kz1, Kz2 like that respective permeability value in the layers, and Kjd maybe I can take consider as a Kjd is not required. Kjd we have to find out equivalent permeability of the layer which is taken is here. Now, considering to compared to previous case, what is the difference? There summation of quantity was equal to the respective flow, but here since its flow is taking place like this in the different layers, the flow through each layer should be constant, otherwise it will continuity of flow will not be satisfied. So, Q should be everywhere same, only head loss will be different in different layer. That is the point to be kept in mind, and total head loss will be summation of the head loss in respective layers. So, this is the point you have to keep in mind, then only you will be able to derive quickly this one. So, total flow Q will be A Kz1. So, these are all are same, because as I have told you that continuity equation to be satisfied, and then this is equal to, now if I express in this form, then again this is the form I can write considering. So, here actually A is there, here everywhere A is there, this is what A to be removed, because I am considering unit area. That means I can consider a unit area like this, this is the area through is taking place, flow is taking place. So, that unit area, if I consider everywhere it is same area, so A can be removed. If I remove the A, then our equation becomes only Kz into I, Kz into I, like that. So, now if H1, H2, H3, Hn are head loss across each layer, then your Kjd into I will be Kjd into summation of head loss divided by H. This is the I will be how much? This is the head loss over what is the distance H. So, that is the I. So, this is the thing you have to keep in mind. Now, next one you can see, now Q equal to I can express in this form, Q I can express in this form, again Q I can express in this form, I can Q also can express, everywhere Q is same for different with respect. So, H1 I can calculate this way, H2 I can calculate from this way, H3 I can calculate this way. So, because Q everywhere same. So, then I can find out this, and this one I can substitute, because in the previous slide I have shown head loss H1 plus H2 plus H3 plus Hn, and I can take H1 from here, I can substitute here, H2 from here, substitute here, H3 from here, substitute here, Hn from here and substitute here, and then I simplify, then our Kjd will become H divided by H1 by Kz1 plus H2 by Kz2 plus H3 by Kz3 plus like that Hn by Kzn can be written, and which I can be written in a very generalized form, that Kjd will be H divided by summation of Hn by Kn. That means, respective layer what is the thickness divided by K, you find out summation of that, and H divided by that will be your Kjd. So, this is the two formula, that means, when it will be Kz H actually no Kx E, that means H1 Kx1, H1 Kx1 plus H2 Kx2 etc. divided by H, whereas in Z direction H will be somewhere here, and H by K, summation of H by K will be here, and then from there we can find out the permeability, equivalent permeability of the layer, multiple layers with different permeability of Kx1, Kx2, Kx3 like that, or Kv1, Kv2, Kv3, or Kx1, Kx2, Kx3 like that. Then one for horizontal plane, when it is, then equivalent permeability equation is this, and the flow is taking place in the perpendicular to the bedding plane, this is the value can be used. With this I will close here. Thank you.